Earthlings. This is Grog. I'm from another galaxy. Hey! My friend Grog. Wait a second, didn't I say that he came from Grog? That's right, my name is Grog. I was actually named after my planet. I am the leader of my people. No, I'm just kidding. Hey, come on, Mr. Rowe, really? Sorry, I'm just not really good at the alien people. Hey, let's get down into math here, all right? As you can see, we're still looking at our same overreaching kind of topic here about making like units pictorially. This is what we've been focusing on for this topic. Of course, we have our objective for this particular lesson. Again, this will come out in our concept development. And as you can see, this looks just like previous objectives. Students will be able to subtract fractions with unlike units using the strategy of creating equivalent fractions. And the only thing that we're looking at that's different now is now we're going to be subtracting. Okay, the key here, keyword subtracting fractions, where before we were adding, if you recall. And so we're going to be doing it with unlike units. Therefore, the denominators are going to be different. They won't be the same. And I think we'll go ahead and get started here. So here we have the application problem. The problem here says a farmer uses 3/4, wow, 3/4, okay, of his field to plant corn. It says 1/6, I like doing that, fun, of his field to plant beans. So we have corn and we have beans here, and it says, and the rest to plant wheat. And what fraction of his field is used for wheat? Well, something to kind of keep in mind here, I'm going to go ahead and write this down. We were talking about, in I believe a previous video, about the RDW method here. And basically, we learned that R really stands for the read, and I even like to emphasize reread. The D is the drawing, and then of course the W is for write. Okay, did I say that right? R is for read, D is for draw, W is for write. And so, with that being said, this is something that I want to make sure that I take special time and read and reread. So again, things that in this problem here, it gives us the actual fraction of the field for each item here. But something that we need to kind of keep in mind here is, remember, the field is going to be our whole, if you will. Okay, he only has one field. So when we think of a fraction, and we think of a fraction is less than one whole, it's important to remember that the field itself is the whole. Okay, so that way he doesn't have 1 whole and a half. It doesn't say that. It's all based on the fraction of that field. And of course, we're trying to find out how much of the fraction of the field is used for wheat. So what I did here, I went ahead and put a couple of area models here. As you can see, I went ahead and I showed both the 1, 2, 3, 4, 5, 6 that I'm going to need for this 1/6 here, okay? And I also separate this one into quarters, again, because that denominator lets us know that we have quarters. Okay, so I'm going to go ahead and get my crayon like I normally do. How I love to color, and then that's going to be just 1/6 here, so we'll go ahead and color and shade in 1 here. And that shows my 1/6 of the field. Okay, remember, this is my whole, the whole field. And this is part of that whole field, but I'm showing it on a different model here to indicate how much. Here we have 3/4. I'm going to go ahead and, let's go ahead and just shade this one in 2. So that's 1/4. Now I have 2/4. And then there's here 3/4. Okay, so now I have 3/4 of my field is corn. So I could show this, that this is the corn. And this, of course, is the beans. Okay? But we need, it said the rest of it is going to be wheat. We don't know how much that is. Okay, what I think is important here is understanding that the 3/4 and the 1/6, if we were to add those together, okay, if we were going to add these two together, that would let us know how much the farmer uses for corn and the beans. And then maybe then we could subtract our 1 whole, which is the whole field, and subtract our fraction of beans and the corn that we already have added together, and figure out the rest would be for wheat. Did that make sense? So what the problem here is we can't add the quarters, right, and the 6 together because they're different sizes. So what we could do this, and we've done this before. Good. I'm going to go ahead and just make a copy of this. Now what's interesting is I could draw these lines out to show you, but indeed we have quarters here in quarters in 6. If I were to just be able to bring those together, see, then I could still show my quarters here, and I could show my 6 going this way, and then it would also break that up into even a smaller unit, a unit of 24ths. Okay, so what I'm going to do here is I'm going to go ahead and put that there, and then I'm going to go ahead and make a copy of this one here, and if I put that right on top, see, now I have what I'm looking for. And I'm also going to group this together here real quick so I can move it around. So I'm going to bring this down a little bit. So now I'm going to go ahead and put, see, now I can show that amount here, and I can show that amount here. So what I'm going to do here is I'm going to go ahead and make a, well, no, let me make a copy of this one here. That would be easier. Okay. So all I'm going to do is transpose this. So I'm going to take this and show that on my new model. Okay. See that? And I'm going to take this down here and show that as well. Okay. Now that I've basically transposed and brought them over here, you can see that I have the same quantity, but I've had my area model divided up into even smaller units, units of 24ths. As you can see, I have going this way, I would have the 6, and then here's my 4 quarters, and 6 times 4 is 24. So each unit here, so my units here are basically 24ths, and I can write that as my unit fraction of 1/24. Now I can simply add. See, here I have 4, and then I have 24. Here I have, well, you know, I have 6 going across, and then 3, that's 18 24ths. So now what I can do is I can simply add 4 24ths plus 18 24ths is going to equal 22 24ths. Okay? See how I did that? And basically, what I'm trying to find out is not how much the corn and beans together. I'm looking for what the wheat is going to be. It says here what fraction of his field is used for wheat. So I need to figure out that fraction. This doesn't give it to me. All this does is tell me how much the corn and beans are together. However, if it's just one field, see what we can do now is we can say 24, see, over 24, and this is kind of getting in my way here. Let me see if I can move this guy here. Okay, come on down. There you go. Perfect. We'll put you right there. I can live with that. So now, here I have my 24 24ths, because that's one whole, 24 over 24. And now I'm going to go ahead and subtract then, and I'm going to subtract here the 22 24, because that's the other 2 crops. Okay, and you can see I'm left with just 2 over 24. Now 2 over 24 can be also shown as a reduced fraction. And as you can see, we always look for the common factor that they both have. Like 2 has 1 and 2, and 24 has, well, quite a few. 1, 2, 4, 6, 8, 3, and 24. There's a lot of factors. Factors, you know, when you multiply them together, will give you this number or product. So here I could divide out a 2 on the top, and I can divide out a 2, and that'll give me a more reduced fraction, which is going to equal 1 over 12. Okay, so that means 1/12. So the farmer then uses 1/12 of his land to plant wheat. And this is something on a question. I mean, I should write this out for my RDW, but I'm going to just say it, and then the farmer, okay, uses 1/12, and I'm going to put dot, 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 okay, of his land to plant the wheat. Just for the interest of saving some time. Now, this is one definitely model. Now, we could show all 3 of them together on another model, but I just wanted to problem solve that. All right? And let's go ahead and do this. Now, going on to the next page. Now we have our concept development, and we're looking at here, that's this problem here. It says 3 boys minus 1 girl equals, okay, well, when you think about it, you know, we can't solve that. See, 3 boys minus 1 girl, you can't do it. We can't. But if we rename, keyword rename them as students, then we could subtract a number of students. So if we said 3 students minus 1 student, we would have 2 students, right? So basically, that's what we would try to do here in this problem here. That's why I put this little thing here. All right, so let's come down and do a real problem here. I say a real problem, one that deals with just numbers here. So now we have 1/2 minus 1/3. Okay, again, I quickly put up area models because I want to be able to represent that. So I'm going to go ahead and get out my crayon real quick here. And then I'm going to show my 1/2 by coloring in 1/2. I'm also going to show my 1/3 by coloring in 1/3 because this is one piece out of 3, and here I have one piece out of 2. So I've shown that fraction. And now what I can do is, just like I've done in previous, where'd that line come from? Oh, it's because I'm dragging it along. Let me go ahead and get my eraser really fast. There we go. Goodbye. Now, what I'm going to do here is, actually I want this. I'm going to go ahead and do like what I've done before. See, if I make a copy of that, and I make a copy of that, basically this is my halves, and these are my thirds. Now, when I take that and bring that over and really transpose that on top of showing that, you can see that halves and thirds I could make sixths because I have 6 there. And this way I'll be able to subtract, because remember, I can't subtract unless, okay, I have the same unit, and I don't. These are not the same size. Trying to get them as close as I can. Maybe something like that. I guess that's close enough. Yes, I could live with that. So I'm going to just make a group and then another copy here. Because I want to go ahead and show like we did last time. See, we just moved that down. And this is something you'll be able to do on pencil. Now you have 3 here and you have 2. Well, we can write those down. Get my pen out. Obviously we have 3, 6. Which means that was equal to our 1/2 that we had up here. And then down here we have 2 out of 6. Okay? So now when we look at this, we're subtracting 1/2 minus, okay, 1/3. So basically we're going to do 3 6 minus 2 6. But this problem really just suddenly got really easy, didn't it? Is going to equal 1 6. Now let's show this using, let me get another color, like something really, like maybe blue. Because here's our 3 6, and you think about taking 2 6 away, so we're taking 2 of these away, so we could actually show it like on our area model like that. See, now we're basically showing you that right here, this amount is 3 6, okay, minus 2 6 equals our 1 6. Okay, I say okay a lot, don't I? Okay. On to the next problem. Oh, we got our chimp back again. Hey, bud, what's going on? That's kind of weird. He's in a box. Wonder why he's in a box. Interesting. Must be some reason you're in a box. Duh, you're hiding something. That's what it was. It says fractions with a numerator of 1 are called unit fractions. Oh, so these are unit fractions because you have a 1 in the numerator. I see. That's what you're trying to hide. Got it. Okay, I'll let you stay there. No worries. You know what? For your good work, my friend, I'll give you a banana. Here you go. Eat up. All right. Are you not wanting to eat them? Eat. Didn't I have it right? Oh, no, it's not eating them. Or he's not eating the banana. That'd be terrible if the banana was actually eating the chimp. Okay, well, I'm supposed to eat them. I guess my technology failed me here. I just put it in your mouth. There you go. Anyway, on with our problem, right? Let's go ahead and do this as well. So now we have 1/3 minus 1/4. Again, I'm going to go through this quickly because we just did this on the last problem. It seems kind of simple. We represent our 1/3. Okay, we need to represent our 1/4. There we go. 1/3, 1/4, 4 equal pieces. Okay, now I can see that. Now, quickly you need to think, okay, how can I subtract these because I don't have the same denominator there? Well, we talked about it. If I could take and make a model of thirds and quarters together, that would make it happen. So here I have my thirds. Here I have my quarters. Okay, see, and just like that, I have twelfths. Okay, so now I can do, by grouping these together, let go of him. Okay, and so now I have my twelfths. Taking that down, look at that, moving that right down like so. Now you can see that we can rename our new fractions here. We have 4 twelfths. And over here we have 3 twelfths. And that's really what we're subtracting. So we're trying to take 3 twelfths from the 4 twelfths. Well, the 4 twelfths, we'll let that happen. Let me get a pen so I can mark that. See, we're going to take how many away? 3. We're going to take 3 away from the 4 twelfths because we're subtracting. And what's left? 1 12th. So not only have we written it out and shown it this way, and we've explained it, but we've actually shown the area model that goes along with that. Okay, on to the next problem. Yay! And let me do this for 2. Let me see here, what am I doing? Okay, so let's take 2/3 minus 1/4, and you may have noticed that the other problems that we did, they were, they always had a numerator of 1. Now this one here, you can see we have a 2, and we talked about that those were like unit fractions. They're a little bit easier to manipulate, easier to use. Now might be a little bit more challenging. Let's see. So I'm going to go ahead and first do this. Let's get our crayon and represent. Okay, so 2/3. So I'm going to color in 1, 2. That's 2 out of 3. Okay, kind of sloppy. And then 1/4. There we go. So now I can show that, and now I need to rename them, right? Because we're going to go ahead and rename them. So I need this here. So I can show thirds and quarters, which we just did that in the last problem, right? And that was basically, oh, wrong one. Nice try, Mr. Worrell, but I don't think so. All right, so looks like I got darker though, huh? There's 2 on top of each other. Very cool. I never even thought about doing that. You could make it there. Doo-doo-doo. Yay, that was fun. Okay, so now we can go ahead and move them. This time I'm just going to do this so I can keep the other one up there. Oh, not yet though. Am I not ready? Because here I only have thirds and here I have quarters, but again, look at that. Just like that, I have 12ths. What an easy way to find, and later you'll probably learn that that's called, it is the least common denominator. That's the words they use to describe what we're doing here. But we get the whole, let's group that together, if there is any grouping involved. That'll work. Nah, I can't have it exactly how I want it. Now you can see how that looks when you put it on a area model of 12ths rather than our thirds and quarters. And you can see here we have 2, I'm sorry, 1, 2. If we have 8, oh, go back up. Didn't get my pen right. Come back. Here we go. I think we have it now. 8 of our 12, and then we're going to be subtracting, and then we have 3 of 12 there. Okay, and again, this is a simple subtraction. This gets really easy now because you're looking at this and you're actually trying to take that quantity away from this. So let's just do that. Let's show it on our model. You take 3 away, what do we have left? 1, 2, 3, 4, 5. And that's 5 out of how many there were? 12s. Okay? So we'll put 5 12s. Is that cool or what? I think that's pretty cool. But you know, something's cooler. Woo! Hey, what do you... Whoa, where did you come from? Hi, Mr. Worrell. Hey. You came back, huh? Did you finish the banana? I don't see it. Okay. All right, moving on. Okay, last problem here. I believe this is our last page. Yes. Oh my God, what's this? Oh, okay, a lobster. Okay, what are you doing here? That's kind of strange. So one more quick problem since we've been cruising along. I mean, isn't this easy? That's why I think we double up in a couple of our lessons. It's just really easy. We have 1/2. We show our 1/2. Okay, we have 2 7ths. 2 7ths kind of a weird one. 1, 2. Okay, I'll make it a little bit darker. Now, this shows the 1/2 and the 7. The 2 7ths. We're subtracting. Okay, so we're going to basically be taking this, and we can't subtract 7ths from halves. Okay, can't be done because they're 2 completely different sized units. Therefore, we could do this. Look at that magic we have. You got it, 14. And we'll do that one there. Now we can basically, let's group them too. So there's a slide, and we'll go ahead and make a copy of that. So leave that up there. You can see how many units it ends up taking now. See, the 1/2 takes up a lot of 7ths here. So now we have basically have a total of 14 units here. Okay, and over here we have the same, but we have 4 out of the 14, where here we have the 7 out of 14, which is 1/2. So let's go ahead and do the subtraction. Okay, so we have here 7 out of 14 minus, and then we have 4 out of 14. Okay, now this is again what we've done before. Let's go ahead and show on our model us taking away, subtracting 4. So we're going to be subtracting 4. So there's 1, here's 2, here's 3, and there's 4. And what does that leave? 1, 2, leaves 3. 3 out of 14. And it gets that easy. Pretty amazing, my friends. And I think you need this, don't you? Yeah, I didn't give you the rest. Can you see that? Yeah, I think so. Sure hope I spelled it correctly. Okay, my friends. Adios.